Okay, let's take a look at the practice test. In the first one, you've got, is it 5 on this side and 15 on the other, right? And then 15 over here. Okay, you know what's going to happen. This one's heavier than this one, so it's going to go like this. And the first question says, the following masses are strung together over frictionless pulleys. So we know that FF is 0 because it said frictionless. So basically we've got some weight here and we've got some weight here. On this side, weight is mass times gravity, 5 times 9.8, which is what, 49? And over here, weight is mass times gravity, and that's 15 times 9.8, which is 147. These forces are actually in a tug-of-war against each other, right? One is counteracting the other. They're kind of in the opposite direction. It's like a tug-of-war. So when we look at the net force here, it's 147 minus 49, which is 98 newtons. How much mass is the 98 newtons moving? Total mass moving? 20. Force net equals ma. All our problems end up here. This is the tricky part to find. So 98 newtons equals 20 times A. A equals something in meters per second squared. I don't know what that is. 4, almost 5. What is it? 4.9. Okay. Done with that one. The second question, this is number 1. The second question says, after testing the system in question 1, it's found the acceleration is 3. The acceleration should be 4.9, right? Okay, let's put that number 1. The acceleration was 4.9 meters per second squared. So we have that up there. And we also know that the mass of the system is 20 kilograms. Okay, we know that. All right, second question. Well, we test this thing and we put it in the lab and we test it. And in number 2, we find out the acceleration is only 3 meters per second squared. So it's not going as fast as it should. It's not accelerating as fast as it should, so there's some friction involved. Well, what kind of force makes 20 kilograms go 3 meters per second? We could figure that out, right? Obviously, the net force in reality acting on this was 3. We calculated it to be what? Up here in number 1, the force net was 98. But it obviously isn't 98, is it? Because in the first one it was frictionless, and this one we're saying, well, we tested it and it is 3. So if you looked at mass times acceleration equals F, 20 times 3 equals F, F is 60. It acts like 60 newtons is acting, but it should be 98. Where are those 38 newtons? Friction. Friction. Right? There's friction involved. So the difference here, the force due to friction, is the difference between what it should be and what it is. 38 newtons. Now, the question was 98 minus 60. Right? The difference. What's the coefficient of friction? Well, force of friction is the coefficient times force normal, which is weight, right? The coefficient of friction is right here. So that equals FF over Fn. What's Fn? What's the weight? What weight are we dealing with? How much weight is moving here? 5 plus 15 is 20. Yeah. Weight equals mass times gravity, which is 20 times 9.8, which is what? How much weight? 196 newtons? Is that right? Isn't that how much is moving? Yes or no? Yeah. So we look at the coefficient of friction Force due to friction is 38. The force normal is 198. What's the coefficient of friction? 38 divided by 198.
Isn't it 196?
Ah, my fault. 196. What's the coefficient of friction? 0.1 what? 0.19. 19. Very good. It's working backwards. It's thinking above trying to fit everything into an equation sometimes.
Recommend test.
Would that be like a bonus?
Do it right yet.
Okay.
We use our notes on the test. Because that would be awesome.
You think it'd make it worse or better?
Worse.
Way better.
Shut up. I'm gonna slap you so hard.
That's awkward.
You're feisty today, Mick.
He just said it'd make it worse.
No, you're feisty.
I know.
Number 3, calculate the acceleration of a car that has a mass of 2,000 kilograms, a coefficient of friction of 0.32, and an engine produces 4,000 newtons. Oh, we got to write all this down. Mass, 2,000, right? Coefficient of friction,
If I get this right, I'm gonna get myself
Me too.
0.32.
16.8.
Force of the motor, which is force applied.
What?
Force of the motor is force applied. 40,000 newtons. Okay, flat, little car. Okay, it wants to go this way. Friction's making it go this way. It's got some weight to it. All those things. Perfect problem. On a flat surface, our force net has always been force applied minus W. Excuse me, minus force due to friction. Do I know force applied? Yes. Do I know friction? No. Could I calculate it? Yeah. What's the weight of the car? Mass times gravity? 1,600
Yes.
in newtons. So force due to friction is coefficient of friction times force normal, because weight and force normal are the same thing, remember?
I can't see what
Okay. So that's 0.32 times 19,600 should give me a force of friction. And how much is that force?
6,272.
6272? Okay. So I know force applied is 40,000. And I know force due to friction is 6272. So what's the net force? 33,
728.
excuse me,
33.728.
728 newtons. Now, force net equals mass times acceleration. Is this what we want to solve for?
Mhm.
Acceleration equals F net over M, which is 33,728 divided by the mass, 2,000. What's the acceleration?
16.864.
16.864. About a little less than 2 G's. They're sitting you back in the seat pretty good there. Okay, must be a fast little car. Get it right, Sandy?
Yeah, I did.
That a girl. Good
It was
deal.
only because I used my note.
Don't race yet. Okay, we're on a race weight.
It's only because I looked at Father Tom.
The reason we got
That's
it
only why I didn't
Yes.
get it. Otherwise, I would not.
I didn't know that 40,000 was.
Who did?
One last one. Basically, the next one is the same problem, except I stuck it on an inclined plane instead of a flat surface. Same thing. We got to find force applied. We got to find force due to friction. We got to find force net. Same problem, except it's on a slant versus a flat surface. Are you good to go, Sarah? All right.
I did this one right.
Yeah.
Numero 40. All righty. 30 kilogram block, 50-degree incline. Boop, boop, boop. This way's 30. The angle's 50. Okay. And coefficient of friction is 0.12. Okay. Let's talk about this now. We know that there is a force called force parallel that pulls it down the face of the ramp. The thing's got weight that acts to the center of the earth, and it's got a force perpendicular, which is a component of that weight. We know a couple things. We know that sine of the angle times W equals force parallel, and cosine of the angle times W equals force perpendicular. We know those two things. We also know that this thing weighs 30 kilograms. So if we were to calculate W, mass times gravity, 30 times 9.8, is that 294 newtons? Okay? So, let's do force parallel equals sine of 50 times 294, get an equals. And let's do a force perpendicular equals sine of 50 times 294 and get an equals.
So does force parallel always equals that, and then force perpendicular always equals Fn? I didn't know how else.
Yes,
Okay.
yes. The question was, is this the force applied in these?
Yeah.
Yes, as long as there's nothing pulling it up the ramp. And is this force normal? Yes.
Okay.
Okay. So let's just talk for a second about these numbers. What'd you get for force parallel? 225 roughly. What'd you get for force perpendicular?
188.
188. Okay. Now we know that force net equals force parallel minus force due to friction. We got force due to friction is the coefficient of friction times force perpendicular, so that's 0.12 times 188 equals force due to friction. What is that number? 22.7? Okay, so force net equals 2 1/4, 225 minus 22.7, right? And what's force net equal?
202.5 divided by 3.
202.3?
Sure.
0.5? Okay. Now, there's your force net. I know force net, I know mass, I can get acceleration. F net equals ma. A equals F net over m. Force net is 202.5 divided by 30. My acceleration is this.
6.7. This one to that.
Very good. Study, study, study. Erase your problems, write them out, do them over, do them over, do them over, do them over.
I'm just gonna keep doing
To
this
get comfortable.
more.
Organize your equations. Study. I would spend at least 2 hours over the weekend working on this stuff. Test is Monday, if I were you.
You got it all?